How to make, use, and calibrate a thermocouple. A thermocouple is a device that measures the EMF across two junctions of different metal alloys, with a temperature difference at each junction. It can be used to measure temperature because of this EMF. EMF, or electromotive force, is a fancy term for voltage applied to a circuit. Here's how it's made. A wire of a metal alloy is joined tightly to two separate wires of a different metal alloy at each end. A multimeter is set to a voltmeter calibrated to millivolts. Leads are connected as required. Each lead clip is connected to one of the ends of the thermocouple wiring. One junction, the point where the alloys were joined, is kept at a fixed temperature as a reference. Here it is the ice bath, while the other is heated or cooled. Here it's a beaker of hot water. The ice bath should be at a constant temperature, such as 0 degrees Celsius for convenience, that allows the thermocouple to be calibrated. Heat causes the atoms in the metals to vibrate, and electrons do too. The outermost electrons are free to move in a conductor and move away from each other with thermal energy. This results in one end having fewer electrons, i.e. a slight positive charge, and one end having more, causing a slight negative charge. This produces the EMF, and this happens due to the temperature gradient. Different alloys are used as the movement of electrons in each is different, causing potential difference to occur. The temperatures of the reference and measurement junctions should be noted using a calibrated thermometer. A very small EMF should appear on the voltmeter when the wire junctions are placed at each temperature point. After repeating this process for various temperatures, a calibration curve can be drawn. Notice that the graph is an exponential power curve. An equation model can help find the temperature for any EMF. Take, for example, this equation that describes the graph. Rearranging the formula, you can solve for T. Thermocouples are generally used for extreme hot or extreme cold temperatures, such as in industry or physical sciences. So unless you're working with furnaces or experiments going near absolute zero, you might be better off just using one of these.